Hey, Richard, I just requested remote control of your computer so I can change my own slides.
That's a good thrust here. Maybe just barely.
Excellent social engineering there, sir.
Yeah.
Excellent.
Does that work? Can you share? Can you move my mouse around?
He also hopped into your bank account.
Yeah, there we go. Okay, cool.
It's a very odd way of doing it, but whatever, it works.
Yeah. Let me turn that off. All right, so I'm going to talk about file systems. I've been a little bit ill this afternoon, so the diagrams I wanted to make, there aren't any diagrams, unfortunately. But I took some pictures instead. So all of this stuff is basically Linux related. So although it's relevant to the Pi, it's also going to work if you've got a Linux laptop or anything like that.
Sorry.
Richard, are you moving me around?
Yeah, sorry. Go ahead.
Okay, so let me be clear to start with what a file is, right? So here's a screenshot of VS Code. We've got a file. They've got names. There's some stuff inside it, which in this case is some Rust source code for my LED bike wheels. It could be a spreadsheet, it could be pictures, whatever, right? And you've got a name, and there's a special kind of file called a directory or a folder, which holds other files. Okay, so hopefully everyone has some intuition for that already, and you don't need to understand that too much. Okay, so files usually go on storage devices. Here's some of the pictures I took this afternoon. That's a USB hard drive plugged into one of my Pis. Here's a micro SD card plugged into one of my other Pis. I think, embarrassingly, I've soldered that colored GPIO connector on the wrong way around. So the colors are wrong, but pretend that didn't happen. So those are storage devices. Those are where files, for the most part, get stored, right? And so we've got these wires that come out of your storage device, and somehow magically your files go through those wires into the micro SD card. And when you want them back, they come back out magically through those wires. So most of these storage devices, so if it's a USB stick, if it's a hard drive, or if it's an SD card, don't understand the concept of files themselves. What they present, if it's 128 gigabytes, say, it presents a sequence of blocks. Commonly, you talk about being 512 bytes long, but they might be different sizes, and they're just essentially numbered from 0 up to a bazillion, right? So your Raspberry Pi can ask your storage device, give me block number 53, and it will say, here's your 512 byte block number 53. Okay, there's no file names, there's no directories, everything has to be exactly 512 bytes long. So you can see how that is storing stuff, but it doesn't look at all like what that Visual Studio Code screenshot looked like at all. Okay. So if you want to change 1 byte in a piece of data, you have to read in the whole 512 byte block. You've got to make the changes you want, and you've got to write it back out again. And somehow you've got to keep track of what all these blocks mean. And that is what a file system is for. So the file system is the bit of code that sits somewhere in your Raspberry Pi in Linux, that on the one side of it, it gives you file names and directories and files that can be different sizes, not exactly 512 bytes. And on the other side, it talks to your SD card or your hard drive or whatever, and says, please read and write these blocks, specifically these numbered blocks, and the file system is what mediates, or the file system code is what mediates those two very different views of storage. So there's a command you can run from the command line called df, which I think I've always interpreted it to mean disk free, but I'm not actually sure if that's true. And on a normal Raspberry Pi OS, if you run this, there'll be two file systems. One is called root or slash, and the other is called boot. And I've put the capital T option in to say, tell me the type. So there's two types of file system here. One is VFAT and one is X4. And you'll see most of the storage on this Pi, the available, or the size, sorry, most of it is this root file system, 29 gigs. And then there's this little about 256 megs boot file system also on that storage card. And there's reasons why those file systems are different. So some of the other stuff about this display, there's a thing called a mount point, which here it says mounted on. So the root file system is on slash, and this other VFAT one is on slash boot. So what that means, the way this works is you start at the root file system and you can descend into directories, but eventually you might come to a magic directory called a mount point. So in this case, boot/boot is a magic directory called a mount point. And what that means is stop looking at this hard drive, stop looking at this bit of space, this file system, and move on to look at this file system instead. Okay, so they don't have to be at the top level. They can be deeply in different directories. You'll see later. So two examples, usually etc password is going to be on the root file system because these are our choice of two file systems, but boot config.txt is going to be on this VFAT file system because it begins /boot. So there's various ways in which file systems get mounted in this way. If you're running a desktop environment, then pretty much if you plug anything in, the desktop environment will detect you've plugged some storage in. It will pick a directory name for you and it'll be called /volumes or something like that. If you're an old school Unix user like me, then you have to do it by hand by typing in a mount command, but I don't particularly recommend that if you've got a desktop environment. Or there's some other commands later on for more specialized stuff that I'll show you. So actually on my Pi, this is the Pi that's sitting next to me, I told it to tell me all the file systems that are mounted, and actually there's bazillions of them. So it scrolls off the bottom of the slide, but that's fine because I'm not going to go through all of them. And you'll see some of them seem to have sizes and some of them seem to be 0 size, right? And have these weird file system names. So for the most part, you can ignore all of these. I'm just going to mention that they're there. And really the interesting ones are these, this X4 and somewhere down the bottom of the screen, the boot one. So there's these two file systems, the VFAT one and the X4 one, and they have, let me see if the next slide, no, it doesn't. They have different properties. There's reasons why you would use one versus the other. And so VFAT is an evolution of what was the original MS-DOS file system that comes from the late 1970s. And it is really simple. It doesn't have many features. It's quite fragile. It's incredibly easy to implement. So you'll see it all over the place. And it's pretty standard. So if you put a SD card with a VFAT file system on into a Windows machine, it will be able to access the files on that, or a Macintosh or something like that. And so one of the reasons that it's that /boot directory is VFAT is because it means you can stick it in your Windows laptop and you can edit the files on there using Notepad, for example. You don't have to install any special software. If you put that SD card into your Windows laptop, and you wanted to access the big root file system, you wouldn't be able to. Okay, but ext4 is much more the sort of Linux native file system. So there's lots of things that Linux has, like permissions, who owns files, extended attributes, all kinds of weird stuff like that. And there's a little bit of extra reliability in there that VFAT doesn't have. So usually you want to store most stuff on something like ext4, and VFAT is this very limited thing that's good for removable devices. So you'll also see digital cameras, anything like that, they'll use FAT as the standard format, because all they want to do is just dump out a file. There's no file ownership or anything like that. It's also sufficiently simple that you'll find it on some other devices. So if you turn on a connector PyPico in bootloader mode, then it will appear as a little FAT file system that you can copy files to. The BBC microbit also looks very much like that. If you connect a microbit to a computer, it appears as a storage device with a FAT file system. And my soldering iron also exposes a FAT file system to this little port on the back, where you can reconfigure how the soldering iron works by editing a text file that's stored on that device. So when I say it's simple to implement and you find it everywhere, probably the soldering iron is the most ridiculous place that I've found a FAT file system so far. Okay. So there are other disk file systems. So I see in the last month, I've seen people talk about ZFS or ZFS and BTRFS, which is B-tree file system. They have some interesting buzzwords around them. So anyone I see playing with storage on a Linux box seems to use one of these two file systems. I don't particularly have much experience with either of them, but they let you do things like have multiple block devices. So if I've got two hard drives and I want to aggregate them or get extra reliability in case one fails, they give you some features for doing that. They let you do snapshots easily. So I can say I want to freeze the file system, take a snapshot of it right now, and then all my other programs can continue working, but I've got this sort of backup of it frozen in time without having to have any special backup programs running. So those are two other sort of more advanced things that you might use instead of ext4. Okay, there's also network file systems. So the one that's easiest to use and I use quite a lot as a single user is called Sshfs. And what this lets you do is mount the remote file system on another computer onto your local computer. As long as you can SSH to that remote computer, you can use Sshfs. So what I've done here is I've made a directory for the mount point. Then I run Sshfs and I've said I want to connect to user pi at Tine, and the home pi directory I want you to make appear on my local computer under mount Tine. So if I use df now, you can see it's mounted. It's an Sshfs file. There's 29 gigs available, which is how much is available on my other Raspberry Pi. And now I can just edit files on using whatever on my local machine as if those files were stored locally, but actually they're stored on the remote device. I very much recommend Sshfs for single user, not too serious work. I've had trouble in the past using it for stuff that you don't want to randomly break though. There are other things around. So the traditional file systems are NFS, network file system, and that's for grumpy old Unix users. And there is Samba, which comes very much from the Windows tradition, and that's for grumpy old Windows users. And you can run the code for that. That will let you take a Windows or a Unix file server and mount those files onto your Raspberry Pi. That's probably, both of these are probably a bit overkill unless you have a reason to use them. NFS, you probably have almost no reason to use. Samba, you would have a reason might be that you want to do file sharing with a Windows, if you have a Windows PC. And you can actually do Samba both ways. So you can also have your Pi, you can have your Pi act as a client and mount a drive from a Windows machine, or you can go the other way around and have your Windows machine mount stuff off your Raspberry Pi. Okay, so network file system downsides. Most software expects that when it reads and writes a file, it's going to be quite fast, because normally it's expecting the hard drive to be connected directly to the machine, and it's going to expect it to be reliable. And the internet and networks in general are quite often not either of those things. So what can happen is, say you get a 30-second internet outage, and if you are just browsing the web, it would appear as your web browsing is just interrupted for 30 seconds and you get annoyed and you keep hitting reload. Anything that's using, say, an Sshfs, it's going to be quite confused as to what's happening now. It went to write out some stuff to disk that it expected to be instant, and now suddenly everything's hung for 30 seconds or so. So network file systems can be fun. Take them with a pinch of salt, though. So another thing, there's a file system called, well, there's a protocol called MTP, Media Transfer Protocol, and it's what things like phones usually use to expose their internal camera storage through their USB ports. And there is a file system for that. So the few photos earlier that I took with my phone, and then I mounted my phone using a thing called JMTPFS. So I mounted /phone. I was now able to just copy the image files onto my computer using a Unix copy command. It's a little bit buggy. You can see that it thinks it has minus 2.7 gigabytes of, here we go. For whatever's going on inside, it thinks it's got minus 2.7 gigabytes of storage used. So something is buggy there. So who knows? But that's quite nice. So this is how I usually back up stuff off my phones, is by mounting them onto a computer and then copying all the files across. So it kind of has the feel of a network file system. So there's a really geeky one. The Sys File System exposes bits of your system as if they were files. So on a Raspberry Pi, there's sys class LEDs, LED0. This is a directory that controls the green LED on a Raspberry Pi. So normally that LED is triggered, I think, by disk access, but it can be triggered by all of these different things you can choose. So you can choose CPU activity, or you can, by default, it's this MMC card, or various things. All these KBD things, I think, are keyboard related. Or you can turn it off and have it by hand. So in that sys directory, there's a file called trigger, and I'm going to say nothing's going to trigger it. And then in the same directory, there's a file called brightness, and you can just write numbers to that file. So I'm going to say loop round forever, write out 255, which means fully bright, sleep a bit, write out 0, which means off, sleep a bit more, and loop round forever. So that's a little shell command. And here's my Raspberry Pi at the bottom. Well, buffering. There you can see the LED is being flashed, and that's happening through this file system access. So these are files as far as the shell is concerned, but they're not files on a disk anywhere. They're files in this nebulous Sysfs that doesn't have any backing in any way. It just controls the LEDs. So let 1,000 file systems bloom. You can implement file systems by writing code in C and putting them in the Linux kernel. There's a really nice library called Fuse, which lets you write them in pretty much whatever language you want. If you use these, then whatever you can imagine and successfully write code to do, you can make a file system do. So if you had a really obscure floppy drive format from a 1980s computer system, and you wired that floppy drive into your GPIO pins or something like that, you could make a Fuse file system that made the files off that floppy disk appear in a modern Unix system or something like that. So the last bit is I'm just going to go through a handful of other file systems and a sort of one-liner of what they do. So if you use Docker a lot, then it will use this thing called overlayfs, which takes lots of directories and makes all the files in all these different directories appear as if they're in one directory. That's good if you want to have a read-only media. Traditionally, that would be a CD-ROM, but people don't do that anymore, and then still be able to make changes on top of that locally. I use encfs a lot, encryptionfs. It transparently encrypts files. So you mount your base drive, then you mount encfs on top of that, and it gives you on-disk encryption. There's a thing called tempfs, what people used to call a RAM disk, that just stores files in memory. When you reboot, they're all gone, but it means you don't accumulate all this stuff on disk. There's one which is usually mounted under /proc on every Raspberry Pi, and it's quite like Sysfs. You'll see lots of internals under there to do with the Linux kernel. There's NTFS, which is the Windows file system is called NTFS. So if you took your hard drive out of your Windows box and attached it to your Pi, you would have the same problem that a Windows machine can't read X4. A Pi can't natively read a Windows file system, but if you use NTFS, you can do that. If you are old enough to still use CD-ROMs, the file system there is called ISO 9660, and there's a file system for that. One of the most interesting ones, I think, is this thing called Cern Vmfs, which is from Cern, the Particle Physics Research Center in Geneva. And what they have is it's like a global file system that everyone who has Cern Vmfs mounted sees the same file system on every computer in the whole world. And if you want to install software that way, then if you install it onto this global file system in a particular way, then every user in the whole world that uses Cern Vmfs will see your software installed. And the last one on this is Xfact, which is like FAT, but it's got a lot of the more modern features, much more reliability, copes with much bigger files. Sorry. So essentially, Xfat is the 1970s file system that is FAT, but brought much more forward into the 21st century. Okay, so that's just a brief overview of what's happening with file systems. Sorry, I didn't have any diagrams. Don't know if anyone has questions. Oh, yeah. Okay. Commentary on ZFS. Yeah. And journaling. Yeah. So, yeah, I don't know if BTRFS has it, but ZFS has a lot of reliability stuff in there. Cool. All right.
BTRFS, the interesting thing with BTRFS is that it's long been expected to become the default file system replacing X4, but hasn't.
Yeah, I've seen I've seen sort of lots of talk about that, and then yeah, every time I install a new system, what's actually happened is the number X2 is incremented to X3, and X3 is incremented to X4. Yeah.
Right.
So I don't know what the politics there is.
It's Oracle.
Yeah.
That's where BTRFS originated.
Yeah.
Though at the same time, ZFS is or has been encumbered by its license, so that's why it hasn't gone everywhere.
Yeah.
So,
yeah, it doesn't seem to stop a lot of people being enthusiastic about both of them though.
Right. Riser was nice, apart from the slight problem. Apart from the slight problem with the author.
Yeah.
No, please let's not talk about rises.
Yeah. So they seem to come and go over the decades.
The odd thing is with all the file systems, and the biggest issue with them is that Xfact turned into a blockage because it was licensed.
Yeah.
And didn't have an open spec.
But
everybody had to support it because it was actually glued into the spec for microSD.
Yeah.
So luckily now it's been opened up.
It's open now as of a couple of years ago. Yeah.
But it's not good.
How does that Cern operating system actually work? It just seems.
It's so it's read only. You can't write to it generally, so there's no permissions problem there in that sense and they're intending to use it for software distribution. So that's not so much of a problem because you don't really want multiple users writing there, and it's chopped up somehow into little zones so that Cern has a thing, and anyone who's publishing software needs to be configured with to say this is where my bit of this file system is being published from, and then I think the actual file transfer happens using HTTP, I think, and then it gets cached locally.
I hope it's encrypted. No,
it's for public software. There's no need to encrypt any of it.
Like HTTPS.
Yeah, probably. It's probably HTTPS. Yeah. Yeah. But it's a very special purpose file system because it's basically designed for publishing stuff that is not super secret and not going to be edited, anything like that.
Well, it always comes over as a good idea, but why does it need to be a file system? Because we're in the state.
It solves there's a lot of cultural problems in high performance computing. Well, there's a lot of cultural artifacts in high performance computing, which I would call problems, not call a problem. So people are very used to having everything on the file system, even as their computers get ridiculously large.
Yes,
so,
but at the same time, you can make a file system literally out of anything. You mentioned Fuse. So, for example, Fuse can make a file system.
It's Cern Vmfs is Fuse running HTTP, basically.
Right. It's a thin layer file. It's not really
It serves the cultural need of the community which it lives in, which you may or may not agree with those being the correct cultural norms, but disagree with the cultural norms rather than with the file system.
That Sshfs seems really useful.
Yeah, I really like it. It's fun. Like it's a little bit. It goes weird when stuff disconnects. So I wouldn't want to support anyone else using it. But as long as you're like, oh, it's gone wrong, I'll just remount it and make sure I save everything properly. It is a super cool little thing.
Cool. Any other questions? Nope.
Yeah.
Thanks very much, Ben. That was a
Right.
nice, quick run through file systems. Very good. It's not really something I really thought too much about, frankly.
Yeah. All right.